everyone, this is lecture video 6. Its topic is, as you can see, intermediate value theorem. This is a very useful theorem about continuous functions, saying basically that if you have a continuous function over an interval like this, and if it takes, whenever it takes any two values, it has to take all the values in between. Okay, let's try to understand this theorem in more details together. So let me zoom in a bit to statement. This is the formal statement taken from your course book. Okay, what we have here. First of all, let's highlight our theorem. This is an important one, intermediate value theorem. It says, okay, your function has to be continuous if you have a continuous function over a closed interval. This is the assumption of this theorem. So let me write them down in my way so that you remember easily. I know reading statements from course books is not that useful. So let me transform this formal statement into an informal one, which will help you to remember better. So all the theorems has assumption part, and when the assumptions holds, they have this conclusion part. Okay, so what do we have in our assumption box? F is a continuous function, right? So first of all, our function here is F, which is a continuous function over a closed interval AB. See, our interval is here. And what is the next assumption? It also says, soon we will choose a y0 point between A and B. So let's put this down as the second assumption. Our second assumption is we have f of A here. This is point A and its image is here. Our point B is here. You see, its image is f of B. And we choose a number y0 between f of A and f of B. Okay, y0 is here in the middle. Then what is the conclusion? Okay, let me try to figure out the conclusion by drawing for you. Okay, what did we do? We have A here, we have B here, we choose an image for A, and we choose an image for B, it is here. And what else we know about this function? Please don't miss the most important part. We know that the graph of this function is a continuous one, okay? So the graph here is a continuous function. That's why I want to connect these 2 points now with a continuous graph. Being continuity means what? From the previous lecture video, you learned that to have a continuous function between 2 points, you have to draw a smooth connected graph without any breaks and without any jumps. So let's try to connect these 2 points with a continuous graph like this, okay? So you see, if you choose any number y0 between f of A and f of B, then there has to be a number here, let's call it as C, such that C is mapped by this function f to y0. Okay, this is our conclusion. So the conclusion says that there is a number C in your interval such that the image of C is y0 under the function f. So how can we be sure about this? Because we know that I have to connect these 2 points with a continuous graph. Continuous graph means that there is no jumps, there is no breaks, there is no undotted points. That's why any number y0 between A and B, you choose an arbitrary number y0, you can be sure that there is this point C on x-axis between A and B such that f of C is mapped to y0, okay? So here, this is our continuous graph. Here is y0, you choose it arbitrarily between f of a and f of b. Since we know that this function is continuous, there is no holes, breaks, jumps on this graph. This is a very nice, smooth connected graph, so that for any y0 on y-axis, I can find a number c. What is the property of this number c? It is mapped to y0 by our continuous function, okay? You see, since our function is continuous, we can make sure of it. Okay, this is the assumption box. This is the conclusion box of the intermediate value theorem. Let me convert them to boxes like this. Assumption box, okay? That's highlighted, and one more box for the conclusion. And this is our conclusion box, like this, okay. So, and if the assumptions hold, then you can reach this conclusion like that, okay? And why this theorem is important? Because you can use it for two main important purposes. You can use it to conclude that your function is, your graph is connected. And second consequence of the intermediate value theorem is that you can use it for finding roots. Okay, how to use this theorem to find roots? So let me write the title like that. How to use intermediate value theorem, IVT. I will use this shortcut for intermediate value theorem to find roots of your function. Roots of your function f of x. Root means what? Root means numbers such that they are mapped to 0, okay? So let's create some more space here. How to use intermediate value theorem to find roots. First of all, to be able to use the intermediate value theorem, you need to check the assumptions, right? Check first. Your function is continuous. Our function should be continuous. You have to check this first, and then you have to find a number a which is less than 0 and a number b which is greater than 0. I mean the image, whose image is greater than 0, okay? If you have two things, then what happens by intermediate value theorem is the following. Let me explain by drawing a graph here. Okay, let's say this point is a. What did we say here? F of a is less than 0, so its image f of a is somewhere here, which is less than 0, right? Okay, somewhere here. So f of a is somewhere here, it's the negative number. And choose your point B, like here. And what did we assume? We assume that f of b is greater than 0. So it is somewhere here, like this. And what we know? We know that our function starts from this point and it ends with this point. Now, I will connect these 2 points with a continuous graph. What does this mean? Okay, let's start connecting these 2 points with a continuous graph. Don't forget, your function has to be continuous. So I need to draw here a continuous graph, meaning that I cannot do any jumps, any breaks. I have to draw a connected graph here. So for example, like this, you see here, right at this point, which I will call as C, what happens? Right at this point, your function takes the value 0, right? So in a way, if you want to fit this story to the statement, you are choosing y0 value as 0, and you make sure that this 0 value is attained by a real number C. So if you have a negative value and if you have a positive value on your function, on your graph, and furthermore, if your function is continuous, then you can make sure by intermediate value theorem that your graph has to cross x-axis. Okay, this is the crossing point, which I call as the number C. So I cannot pass from this point to this point by a continuous graph without crossing x-axis. So this point, the crossing point, which I call as C, is the root of my function because f of C is 0. Such points are called as the roots of functions, okay? So how do I make sure that there is this intersection point? Because my function is continuous, and by intermediate value theorem, there has to be a number C here such that its image is 0, such that your function crosses x coordinate. Okay, there is another situation that may happen. Let me put an or here, or the image, okay, we are still working with a continuous function here. The or part is the following. The image of A may be positive, the image of B may be negative. So just the reverse of these equations. Then what happens? Okay, let me draw this similar graph again. This time, what did we say? We say that the image of A is a positive value. It was negative here, be careful. And let's choose the point B somewhere here. And the image of B is negative this time. Okay, like this. F of B is under x-axis. So if your function is continuous and it has one image under x-axis like this, and it has one image above x-axis, now by intermediate value theorem, by connecting these 2 points with a continuous graph, you have to pass over x-axis somewhere between A and B. So this is ensured by intermediate value theorem because you have to connect these 2 points with a continuous graph. Continuous graph means that you cannot do such jumps to pass under x-axis without crossing it. No, this is not the case because you need to draw a continuous graph. That's why you have to intersect with x-axis to reach this point, to reach a point under it, okay? So that you make sure that there is a point C between A and B such that f of C, what is f of C? You see the image of C is 0. Again, you choose this y0 point as 0 and make sure that this point C is mapped to 0. Okay, so it is the root of your function. Okay, so again, there is a point C here between A and B such that, like this. And this is ensured by intermediate value theorem, of course, by IVT, This is the core idea behind this theorem. I hope you understand it. Okay, there is one more thing that might happen, or maybe your graph intersects x-axis more than once. Okay, let me draw the corresponding situation here. Okay, f of x is continuous function again. F of x is continuous. Okay, let's choose fa bigger than 0, fb less than 0. Just like the case here, right? Okay. F of a is a positive value. B is here. F of b is a negative value like this. So from here to here, you need to connect these 2 points with a continuous graph. So your function may behave also like this. You see, I didn't do any jumps, any breaks, any holds in my graph. This is still a continuous graph. But in this case, you see, you intersect x-axis more than once. This may also happen, you see. So all these points, let's call them as C1, C2, C3, and C4, all these points are now the roots of your function, because at all of them, what is the image of your function? 0, right? That's why you may have more than one root, like this. Maybe more than one root may happen, okay? Don't forget this. But what intermediate value theorem makes sure for you is that there is at least, okay? That's why in the statement, we need to add here, there is at least one number C between A and B, one number C between A and B such that f of C is 0 in these two cases. So there is at least one root, okay? At least a C such that its image is 0, at least a number C, its image is 0. So you know at least one root we have, but there may be more than one roots if your function behaves like this. And to prove that there are more than one roots, you need to work harder. And it is the topic of the upcoming chapters. We will cover that part later. So let me show you an example how we use intermediate value theorem to prove that your function has roots. Show that the equation, okay, there is this equation here, has 3 solutions. In other words, 3 roots in this interval. So such points are called roots of your equation, as we mentioned before, or you may call them as zeros of your functions too. So solutions, roots, zeros, they all mean the same thing. Okay, so what is the function here for which we will prove there are 3 roots over this interval? This is our function, right? So let's take it. So here, x cubed minus 15x plus 1. We want to prove that there are 3 roots. That's why we want to use intermediate value theorem, and the ideas explained here. So I will try to find a positive value of the function, a negative value of the function. Then by intermediate value theorem, it is ensured that at least one number, your function gets the 0 value so that you can call it as a root. Okay, so by trial and error, you will find those positive and negative values. For example, by the way, before passing to that part, of course, you need to check the assumption, the main assumption of the intermediate value theorem, which is the continuity of your function. So this is a polynomial function, right? Polynomial function, so it is continuous everywhere. That's why it is continuous over the given interval. So it is continuous over this closed interval. Okay, then you see the continuity over the closed interval, which is the main assumption of the intermediate value theorem, is checked now. So that we can continue by searching for positive and negative values of your function. Main assumption is checked. Okay, now let's search for some negative and positive values. For example, look at the image of your function at the point -4, which is this endpoint. So you can easily compute it by inserting -4 here, and you will find -3, which is a negative value. Okay, let me start drawing the picture. And so -4 is here, and at -4, I see that the image is -3 somewhere here. And then let's look at the image at -1. Insert -1 here to find the evaluated value as 15, which is a positive value. So at -1, we obtain a positive value as 15. Now, what happens between these 2 points? Now, I have to connect these 2 points by a continuous graph, you see, like this. So here, this is my x-axis, by the way. You see, to connect -3 and 15, which are the images of your function, and you prove already that your function is continuous, to connect these 2 points with a continuous connected graph, you have to cross x-axis at some point here. Let's call this point as C1. So then by intermediate value theorem, there exists at least one C between -4 and 1, 4 and -1, such that, okay, I call it as C1. C1 is 0, just like here, right? C1 is 0. Now, we want to find 2 more roots. That's why you will repeat this process 2 more times, okay? So you can try, for example, F1. Okay, let's try F1 now. Insert 1 here so that you will find -13, which is negative again. So -13 is attained at the point 1. Okay, it is somewhere here, down here, -13. Now I will connect again these 2 points on my graph with a continuous graph, something like this. You see, I have to pass x-axis again by crossing it right at this point. And that's why we proved 1 more root is here by intermediate value theorem. Let's call it as C2. So between these 2 points now, one of them is positive, one of them is negative. Then by IVT again, there exists, this is the shortcut for there exists at least 1 C2 number between -1 and 1, such that C2 is 0. This is the second root, and repeat the process 1 more time by choosing a positive value. You may try F4. Okay, F4. Its image turns out to be 5, which is positive. Okay. So at 4, we find the value 5 somewhere here. Now, from -13 to 5, you need to continue drawing your continuous graph, connect them with a continuous graph like this, so that you have to cross again x-axis 1 more time here. You may call it as C3. That's why between these 2 values, since your function is continuous, you have to intersect x-axis again. So there is at least 1 number C3 between 1 and 4, such that FC3 is 0 again. You see, first root is proved by intermediate value theorem, second and third. And by this way, we proved by IVT that, we proved that there are at least 3 roots, which we call as C1, C2, and C3. The images of all of them are 0. So that's why we call them as roots. You see, that's how you should use intermediate value theorem to prove your continuous function has roots over some interval. So this is the end of this lecture video. Thank you for listening.